Next curve.
Hey everyone, welcome to this episode of Next Curve's reThink podcast episode, where we break down the latest tech and industry events and happenings in the world of semiconductors and Karl's favorite topic, AI. Yeah, and Karl's favorite
logos.
topic.
I got 2 logos, Jim. Beat that.
Yeah, he's beating you, man. You got to catch up.
I've got one that's got a whole background just full of logos if you really want it.
Let's see it. Let's game on.
Yeah, and also maybe at some point quantum. But we're distilling all this stuff into the inside stat.
Hey, why stop there? Let's go to neuromorphic. Come on.
Jeez.
No, I won't be around when neuromorphic finally happens because it's way too future.
Yeah, well, some people argue it's already happening, but I'm Leonard Lee, executive analyst at Next Curve, and I'm joined by some very, very good friends and fellow tech industry colleagues. First off, the inference optimized. How do you like that one, Jim? Jim McGregor of famed Serious Research.
I'm not real. I'm AI.
Yeah, I believe it. And then, of course, Karl Freund of Cambrian AI, quantum, and eventually neuromorphic research. How are you gentlemen doing?
Doing
Awesome.
good.
Doing
my God. We have so much to cover. It's insane. And this year is already starting off as being one that will be very busy for us, no doubt, right?
Oh, yeah.
Okay, before we get started, remember to like, share, and comment on this episode and subscribe to the reThink podcast here on YouTube and on Buzzsprout. And this podcast is for informational purposes only. Statements made by my guests are their own and don't reflect those of Next Curve. We just want to provide a forum for debate and discussion on tech and the semiconductor and AI industry. So, yeah. So I think we have to start with CES. And yes, CES, it was that long ago.
I don't remember CES. That was too long ago. That was over a month
CES
ago.
this year.
Yeah, we had a CES, and there was a lot of announcements, right? I think like the biggest one was probably Intel, with the launch of Panther Lake, right?
For the PCs, I would say that was the biggest
PCs.
one.
Yeah.
But, the show, I would actually say some of the biggest announcements at the show, were data center, where we got a view of Vera Rubin.
Really
from
weird.
NVIDIA, as well as the MI 400 series from AMD, and quite honestly, the underlying theme of the entire show was robotics.
Yeah, robotics. Largely humanoid, right? Isn't that mostly what you saw?
Yeah, largely humanoid, but seeing everyone kind of get on the bandwagon. I mean, even and especially, and I think this is kind of a key part that's coming out, is those companies that really led in autonomous vehicle technology are probably going to be the leaders in robotic technology, especially humanoid robots.
Yeah.
We already saw that with Qualcomm
Tesla.
announcing at the show their new IQ10, so a brand new a part just for robots. And they came out with, leveraging all that automotive technology. They came out with a demo in just 4 months, a working demo at the show in just 4 months. But NVIDIA, NVIDIA is definitely just like AI, they are definitely the leader in that segment with just so many technologies and so many, anything from the silicon all the way up to the models and new models being introduced for different types of AI at the show.
Mm-hmm. Mm-hmm. Yeah, they what was the name of the automotive model that they introduced? It's Anabera or something like that. Do you remember?
Yeah, I keep wanting to say Annapurna, but that's not it.
That's accelerated company bought by.
It's Alpha Mayo.
There you go, Alpha Mayo. Yeah, there you go. Yeah, they announced that, right? But that's less for the robotics, more for like the in-cabin experience type of AI experience, like chatbot.
That is true,
right?
because they already have the drive platform for the command and control systems.
Yeah. And it was interesting to see the West Hall largely, largely absent of a lot of the big name automotive companies that used to be there, right? And less of a focus on ADAS and
a lot of industrial stuff. A lot of industrial stuff from the likes of John Deere and Caterpillar and Case and stuff like that. Yeah.
Right. But pivot toward like cars as a service, vehicles as a service, right? Yeah. I don't think I've ever seen Waymo with as large of a presence as they had this year. And then of course Zeusk, Amazon's Zeusk, that's their own. I would call it more of a autonomous shuttle.
Yeah,
they also were running a few of those up and down the strip. So, and it seems like the West Hall is evolving, right? North Hall.
Actually, and I wasn't impressed with a lot of the automotive stuff because we're still waiting for a lot of that stuff to come out. So you're right. A lot of it was shifting towards the services. However, there was one company that still continues to amaze me, and that's Verge Motorcycles. Now, Verge is actually 3 companies because they have the Donut Labs, which actually developed the motor. They've got this round motor that goes inside a wheel that can be on a motorcycle or a car. They've also got I think it's called Watt, their battery technology company. And they were introducing at the show, they were talking about they are in production with solid state batteries for the motorcycle and for other future transportation solutions. So I was very impressed with that. I've always been impressed with the design and everything else because it's one of the few electric motorcycles I think that will actually feel like an electric motorcycle. Mm-hmm. But the fact that they're in production with solid state batteries, which everybody's been trying to get to for automotive industry, I was very impressed with that.
Wow. Yeah, there were some more e-bikes than before, mm-hmm. But these are not new things, right? I mean, they've been on an evolutionary path for quite some time. But going back to the AI PC, so we had Panther Lake, right? Yes. I went to. Did you guys go? No, Karl, you weren't there. You weren't at CES, right? You were observing, but
my colleagues were at the Panther Lake launch and activities.
Yeah. And so there seems to be a lot of excitement about 18A, and from the sounds of it, mm-hmm. Some of the OEM customers, their OEM customers that I spoke with, they seem to be pretty happy with the Core Ultra Series 3, portfolio. I think they introduced like a 9X and something else. There was 8X.
Karl and I actually toured Fab 52 late last year, which is producing Panther Lake and the future Xeons on 18A. So they are in full production. Now, they didn't land any, they haven't announced landing any customers for 18A. And quite honestly, they were kind of late with the PDK to get a lot of the leading edge customers. But you have to remember that 18A is probably going to be a 10 or 20 year process node. So there's still going to be a lot of customers that may not be on that bleeding edge. They may not be the AI accelerators. They may not be the server chips. They may not be the handsets. But there's everything else that may be able to leverage that technology. So there's a lot of excitement still. And the fact that they're in production with the world's most advanced process node, a lot of people are taking note. And they're introducing the PDK for 14A. Yeah. So at least the 0.5, I believe it is. So that's definitely going to help them maybe get on that leading edge.
Yeah, and based on the earnings call, late in January, it looks like yields are still kind of an issue, but it looks like they've nailed at least the technology, introducing backside power, right, as well as the gate-all-around or Rubin FET transistor architecture. So, I mean, I think that's the thing that everyone has to appreciate. This is always going to be a really tough one for Intel to deliver on. And
that and the fact that it goes hand in hand with the packaging, the advanced packaging technology, and that's really where Intel has its true leadership right now. Matter of fact, I'm going to be touring their advanced packaging facility out in Rio Rancho, New Mexico, on the 24th of this month.
Yeah, and EMIB-T looks really, really interesting.
Yes.
Well,
even the stuff they're doing in Chandler with glass substrates is very interesting too.
Mm-hmm. Yeah, so a lot of interesting things happening at Intel. Actually, some nice, like actual bright spots. Do you know what I'm saying? This year, I think one of the things, like Qualcomm. I was at the Qualcomm event. During Media Day, and they introduced the Snapdragon X2 Plus, right? So that's the let's say mid-tier offering, and so looks like Qualcomm's looking to expand its AI PC base. So that was kind of cool, and it was something that a lot of folks talked about.
Speaking of Qualcomm, we might want to mention they had their earnings yesterday.
Yes.
And the market not happy. But, I think a lot of their projected underperformance expectations is really due to the global memory issue.
Yeah. It is. And they highlighted that. And quite honestly, that's one of the topics we really need to cover here is the fact that they're just the first to really highlight that. I think that we're going to see that from semiconductor companies, through system companies, through even possibly hyperscalers
and handsets.
2026 is definitely the year of capacity constraints. Whether memory's the big one, but also manufacturing. I mean, there's a lot of companies looking to leverage TSMC 3 nanometer and 2 nanometer. That's going to be a challenge for them in terms of capacity. And and Intel's still ramping its stuff, so there's going to be a challenge there. And if that's not enough, geopolitics could actually throw capacity issues in the mix with rare earth materials.
Yeah, and this is the thing that I think we have to watch out for. There right now, there's this shift in the it shift from mobile memory, right, LPDDR to HBM, right? So that's like where everyone's concerned at
and LPDDR. So even the servers are now going to LPDDR.
Right. That's
the next generation Vera Rubin for large contact windows will be LPDDR.
Right. But everyone's talking about HBM because everyone's still thinking AI infrastructure is, that reference design, which is the Blackwell and the Hopper, right?
I agree. But I talk to a lot of startups that are really trying to address the memory wall that is creating because you don't have enough capacity for these new large models and large context windows. Using HBM. So people are coming up with some wild stuff. I was talking to Majestic this week, and they've got a completely different approach.
It's going to be a challenge. I mean, with the big three, Micron, SK Hynix, and Samsung, all kind of abandoning DDR4 to go to DDR5 and HBM, especially HBM. They're leaving everybody in a pattern that we've never seen before. Typically, when memory's constrained, everyone starts double or triple ordering. We actually saw at the end of last year people canceling orders because the price was too high, especially for DDR4 when it's going up 4x or more.
Yeah, and then we're also seeing, I heard a lot of talk about the increased demand in NAND as well, storage.
Mm-hmm.
Yes.
And so there's constraints all across the board, but I think, to the point that we just raised, Karl, about the the kind of memory that's going to be driven by AI infrastructure. It may be less and less HBM. It's the other, it's the types that support inference supercomputing or whatever it is that you're sticking in your.
there's
right?
As you know, I'm a big Perplexity fan, and Perplexity never ceases to amaze me in how it knows me.
Mm.
It knows how old I am. It knows what business I'm in. It knows where I live or where I'm moving. And because once you tell it something, it remembers it. Well, that stuff's all stored in NAND.
So does Gemini. So does
all stored in
ChatGPT.
NAND.
All of them do. Yeah.
Yeah, they all do that now. So that personalization capability that's coming online from all the major chat models, that requires NAND and a lot of it.
Yeah.
And I'm not going to sit around and wait for answers. Right?
Yeah. And so that is another topic that is starting to become a big one, which is the long memory, right, of these AI systems. And so I think the mindset of observers of the industry are still maybe about a year off. Where we're actually going this year, where, last year the talk was all about the memory wall and HBM, but coming into this year, the inference stuff looks very different. And so these are things that we raised actually last year. So,
and it's interesting to see Google's earnings yesterday, right? Because Google came out and said, "Hey, that 95." Is that right? $95 billion?
Billion.
Yeah, we're not going to do that. We're going to do $160 billion in infrastructure investment. So Google stock goes down and everybody else's stock that supplies them goes up. And I mean, the industry is just churning right now from one supply and demand crisis to another.
Yeah.
There's also been a bit of a wake-up call that, has come across recently. And I'm trying to remember who I think it was OpenAI that was talking about it? But, just the fact that, these AI capabilities, the AI bots can replace a lot of the other applications that are out there, whether it's, the productivity apps like Word and Excel, or whether it's, for purchasing. Matter of fact, Humane AI, that's exactly what their CEO is promoting when he was talking to us at the Snapdragon Summit was, listen, every function in my company should be one person and AI. And, we define what it has to do, and then we go and we program it. And the fact is that, AI may lead not just to increasing productivity for each individual, but actually customization capabilities for every function.
Yeah. I mean, I'm not as bought into that whole talk track or thesis.
That's because you're not a programmer.
No, I used to be a programmer. The problem there is it's this thing called the brownfield, and that a lot of these agents have to interface with older systems, and also we're completely discounting the value of the older systems. I mean, look at IBM's result. Their Z series did really well. And I really don't buy the notion that it was all AI. If you look at the banks, they do a lot of transactional. I mean, their transactional business is actually going up. Yes. And these older systems do their job extremely well. You're not going to throw a GPU to do these things. And so I think this is the prevailing misconception out there. I think it was really spurred by this idea that accelerated computing is going to take over everything, and you're going to throw all the old stuff away. That never, ever, ever happens. It never.
Well, you do realize that most of IBM's investment now is in AI, right?
Yeah, right. Well, exactly. And in fact, the extension of mainframe systems with AI, built-in AI, and augmented with additional AI cards is what is enabling banks to do real-time scoring on credit card transactions using AI. Yeah. And so that is a very productive synthesis of these two technologies, and we're going to see the same thing happen with quantum.
Sure.
We're building quantum systems adjacent to GPU-based systems. NVIDIA and others have been talking about this for a while, and it's going to be a major shift.
That was the biggest discussion point at SC back in November. Supercomputing back in November was, how are we going to have these hybrid data centers that have, the CPUs, the NPUs, and the QPUs all operating simultaneously and with each other?
Yeah. Just going back to CES really quick. One of the things that I thought was a really big deal, and I think maybe a lot of folks missed this, was NVIDIA's announcement that they're partnering with Lenovo for the Vera Rubin NVL 144 liquid cooling.
Liquid cooling.
It's warm water cooling. So it's their Neptune cooling system and technology, and this is Lenovo specifically. And that was super interesting. And so like what we had talked about, I think about it a year ago regarding cooling systems, because that's when, about a year ago is when all the water cooling stuff really became a big topic.
Well, that's when we found out that Blackwell just wasn't going to work without liquid cooling.
Yeah.
Exactly.
Yeah.
Exactly.
But a year later, now we see NVIDIA now pivoting toward this other technology. And it is different because it uses, near room temperature water instead of cooled or chilled water. And that has a huge impact in terms of, the requirements for cooling, right? The cooling, the chillers and all that stuff. And so, what we saw at Hot Chips last year, some of the topics around the innovations around cooling systems, as well as, the fancy little cold plates and stuff like that. That's becoming an area of innovation that's driving some differentiation in the systems and the architecture, right? And so I think this year also is going to be an interesting one as we look at the data center facilities and how those are architected. But it's moving now back toward, these, let's say, first generation AI infrastructure cooling architectures for the data center, now back toward traditional, right? Because that's one of the benefits of the Neptune cooling systems, is that you can deploy these in a more traditional data center configuration and with the cooling architecture. So I think it's a big.
It was amazing watching you're exactly right, and it was amazing at supercomputing this year or last year. Now, it looked more like a plumbing show.
Oh yeah,
I mean, there was these big honking pipes and stuff in there, and massive cooling systems, and
from Verve, from Vertiv, from Flex,
Schneider.
From all kinds of companies. Yeah, Schneider. It was everyone is focused on that.
It was just amazing. It was a plumbing show.
Although I'll be honest with you, I think liquid cooling is a key part of it. But I think the biggest change we're going to see in 2026 isn't necessarily from the cooling. It's going to be from how we architect data centers. We can't afford, 2 years at a minimum to 4 years to build a data center. It's got to be, it has to be industrialized. So we're seeing the entire industry take note of what happened to the automotive industry 100 years ago and saying, we need to be able to manufacture these things on a production line and then ship them to wherever they need to be and be able to have a modular solution, whether it goes in a building or whether it's a building itself, to be able to put these things together very quickly. So I think we're in a brand new industrial revolution of data centers.
Oh, geez.
I agree.
Wow. Yeah. And we got a taste of that in Computex last year, right, Jim, when we were there? Vertiv, I think, was showcasing a lot of the modular, I don't know what you call them, data center units. I don't know.
Yeah, actually, Vertiv probably had the best display there. They had a full center display.
Walk right through it.
Yeah, it was incredible.
Yeah. And one of the things I heard, I've been hearing just a lot of lately, and this is probably, something that you and I talked about, Karl, but I'd love to get Jim's reaction to this, is SRAM. just keeps popping up everywhere.
Yeah.
I mean, it sounds like a really boring thing, but it's actually a pretty big deal, right?
You're seeing people develop SRAM, entire SRAM chips. It's kind of turning it on its head. Instead of a CPU, a GPU with a whole bunch of HBM. How about a farm of SRAM surrounded by processing units, all sharing the same pool of SRAM? That's a radical concept, and it really does turn the entire compute architecture on its head.
Yeah.
As we get to this densification of compute, it's required. I mean, memory is a critical part of that. So whether it's in-memory compute, near-memory compute, or whatever solution you're trying to create, it becomes part of that. And we have to remember that we have to. It's the memory, it's the computing, it's the acceleration, it's the I/O, and all of that has to be very, very closely tied together. So it's going to be an interesting time. It's an innovative time. We're going through a period of innovation that I don't think we've seen for 30 years.
Never seen since transistors took over. I mean,
40 years. 50 years, maybe. God, I'm dating myself now.
And so, I mean,
you're still a youngster.
Yeah, but
I worked at Intel back then.
You worked everywhere, man. But no, think about how different of a place we are today than the same time last year.
Yeah.
Right. I mean, the same time last year, it was all NVIDIA. It was all about CUDA. It was all about the GB 200, 300, MVL72.
And it's all about networking.
A unified and literally singular roadmap. And now we're seeing forks all over the place.
Well, we're seeing these forks through a lot of interesting acquisitions. NVIDIA acquiring the assets of Grok. So now that they've got a new type of accelerator technology, we see Qualcomm acquiring, I can't remember the name of the company.
AlphaWave.
Yeah. No, not AlphaWave. I was thinking of the other one that actually does RISC-V. Yeah, it starts with, that does RISC-V based CPUs, and they're targeting that towards the data center, which they talked about on the earnings call yesterday. So we're seeing a lot of innovation, a lot of change. And you're right; it's not just all about Blackwell now. It's
or even
all these technologies.
In Fabrica, Carl, right? Remember,
they were
talked about in Fabrica.
I wanted them to be a client so bad because I thought their technology was so cool. NVIDIA bought them.
This is going to be the year of co-packaged optics. We're going to see a lot of that coming to production this year, to where we're going to be accelerating everything from the chip through light, through optics.
Yeah, I know.
In fact, the hottest
accelerate a lot.
One of the hottest companies in the world right now is Lumentum. Lumentum is the hottest company of the year so far on the S&P 500.
Yeah, that's great.
And they're just going through the roof because everything's going to optics.
Yeah,
maybe people get a little overexcited about it, but it's going to happen.
Yeah,
it's going to be a big deal.
Yeah, I think so. What I heard from the Marvell guys was yes. Obviously, they're trying to extend copper a bit more, right? Co-packaged copper, so CPC that they were touting. I guess we'll have to see, right? I know I'm with you guys. There's a lot of optimism. There's a huge push for co-packaged optics and optical in general. But then, maybe Jensen was right. Copper has to have, a couple more cycles before you ditch it. I don't know. But one of the things that I thought was, obviously one of the things that happened last year that I think kind of spurred all of this was Huawei introducing their cloud matrix, right? That uses they're largely using optical for that system, but coming into this year, I think I don't know. It's interesting to see the diversity that is being spurred by inference, Inference. I don't know what you guys think. I think it's turning out to be a completely different beast than people thought.
I think you're right. And speaking of that, I'd love to get your perspectives, Jim and Leonard, on Cerebras and wafer scale computing at large. Cerebras announced, I think it was yesterday, a $23 billion valuation based on their latest $100 million funding round. 100 million? No, it was over a billion, right? The $1.1 billion round they just did with Tiger Capital and others. And I keep asking myself, and in all honesty, Cerebras is a client, but I keep asking myself, what's everybody else doing? Either is Cerebras is right and everybody else is wrong, or Cerebras is wrong and they're not worth 23 billion. I tend to think the former. I'd be interested in your perspectives. Are we going to see other wafer scale implementations?
I don't know. First off, what Cerebras has done is phenomenal. I mean, the engineering feat of creating a wafer scale solution. But there's other ways to skin the cat. I mean, through die stacking, through multi-chip modules, through everything else. And it's going to be interesting to see. All of these technologies, I think, are on the beginning of their curve. So we don't know how far they're going to go at this point in time. But I mean, and it depends on what you're trying to do. Are you trying to run a massive model? Or are you trying to run a bunch of, millions of smaller models?
Yeah.
And which is going to be more efficient depending on the type of application you're running. I think Cerebras has found a great niche. And the build out, they're one of the few AI startups that successfully transitioned to becoming a service provider, and that through a huge investment from the Middle East to be able to build out data centers to do that. But it's really going to come down to eventually of that ROI, which is what the financial community has really been questioning as of late. Service providers, we're not quite sure what that ROI is going to look like. You can build up a lot of clients, you can sell a lot of data, or a lot of data services if you tank the price or you basically give the services away. But when are you going to make money and how are you going to make money? And I think that's still going to be the challenge.
Well, it'll be interesting to see how OpenAI fares with their deployment of Cerebras. That's going to be the test case, because you're right. Most of their really large customers are in the Middle East. And this was the first time we've seen a global AI service provider adopt Cerebras at scale, at significant scale. So we'll see if that starts the trend you're talking about, Jim. What do you think, Leonard?
I think we'll have to wait out this year to see what the scale out application is. So if it's large language model inference, and that architecture continues to demonstrate differentiation, right? Just performance that can't be denied. Then I think there's going to be entertainment of that architecture. And I think you're making a really good point about this, because I want to talk about Microsoft's Maia 200 announcement really quickly. And I think it represents one of these this movement amongst the hyperscalers with their custom silicon moving toward a transitionary architecture, and maybe moving more toward like what you're talking about with wafer scale and alternative architectures. Because if you look at what Microsoft's Maia 200, it looks a lot like your conventional training microarchitecture as well as system, right? The way it's networked, although we can talk about the networking a little bit later, it is different. But it kind of goes off of that, GB 200, H100 kind of, format, right? Or design. But they start to inject or integrate SRAM in there for inference optimization, right? So they're slowly changing the memory architecture. but I think this is transitionary. I think, with the introduction of CPX, when that comes out, that's going to change the game. And all these guys who are the hyperscalers who really are going to need very power efficient, highly scalable inference compute. They're probably going to make that transition towards something either closer to Cerebrus or some of these alternative architectures that use novel networking and interconnect, right? And so if you look at what they did with Maia 200, what do they have? Like integrated, they have an integrated NIC, right? And they have this two-tier interconnect network, networking. And this is like really, I think this is really interesting because there's a recognition that inference is different. And that it is kind of curious that they can scale up to something like 6,000, in their scale up domain. It's like 6,000 or something like that, right? 6,000 accelerators.
I like how you say inference is different. Every type of inference is different. Every model is different. Every data set is turning out to be.
And agentic AI as well.
That's the challenge. And if that wasn't complex enough, we're moving to a world of mixture of experts,
right?
Where all these things are working together to be intelligent. And we haven't really gotten to what I call collective intelligence, where you've got competing solutions that have to figure out who has the right of way or who has control.
Talking about Malt Book.
So it's going to be interesting. It's I would agree with you. There's a lot of room for innovation. There's a lot of change going on, and there's going to be room for all these architectures because, well, just like in the data center, we've never had a single CPU architecture because no two workloads are the same. It's the same for AI. Matter of fact, it's even bigger with AI.
I think you're right. I think we'll end up with a mass of specialized accelerators, not GPUs, massive specialized accelerators for different kinds of models. And if you want something that runs everything, you're going to use NVIDIA. Right. But if you want something that's really good at this one thing, you're going to go to a company that can provide a really good solution for that one thing and that one model.
Yeah. I mean, I think for training, NVIDIA has the advantage. When it comes to inference, it's very obvious that they recognize that this is a different animal, right? And CUDA doesn't save them. This is where, to your point, Jim, the diversity, what optimal looks like in the diversifying inference landscape, it's just all over the map. It's actually looks a lot more like edge AI, like what I saw at edge AI. Some of the stuff that's happening with CES. No one talks about GPU. When you're talking with the edge AI community, depending on how you define that and think of it, but it's MPU, DPU, right? And maybe some FPGA. So I was at MD&M West, which is a medical manufacturing conference, and I was talking to some folks that were doing computer vision stuff, and they were using FPGAs. I was like kind of surprised. I thought they would use an MPU or a DPU, but
you mean DSP?
Or a DSP, right.
DSP,
sorry. DSP. I don't know why I said DPU. DSPs, right.
DPU is a whole nother animal.
Entirely different animal. They're using DSPs. And so, I think the picture looks entirely different. And then when we look at inference, we are looking at MPUs, DSPs, and these ASICs that are application specific.
And not even that, even CPUs, because a lot of the CPU architectures are integrating the ability to do inference processing. So is it really so? It's a logic element that's designed to run, an AI workload of some type.
Yeah. And, actually, I think CPUs are coming back. When you look at the AMD numbers, right? They for the past few quarters, they've been putting EPYC front and center. It's not necessarily all because of AI, right? I think there's a silent data center refresh that's happening with traditional compute. So, and we hear a lot from the OEMs as well. They're getting their margins and increased volumes in their data center businesses through a lot of the traditional compute, data center compute. So, but wow, that was great. Any other things you want to? I know. Karl likes to keep it short and sweet, but unfortunately,
there's just too much to talk about.
There's too much to talk about. What do you do? I mean, this is going to be a year.
This is going to be an interesting year. I mean, between the elections, the geopolitics, the capacity constraints, the innovation, the innovation. It's going to be phenomenal.
Yeah, it will be an adventure to be sure. So, hey, everyone, thank you for tuning in. Gentlemen, thank you so much. Of course, make sure that you reach out to Karl at Cambrian AI Research at www.cambrian-ai.com. He's on Substack. He's on Forbes. He's everywhere. He's Mr. AI. And then, of course, reach out to our good friend here, Jim McGregor of Tirius Research at www.tiriusresearch.com. And also, please subscribe to our podcast, which is featured on the Next Curve YouTube channel. Check out the audio version on Buzzsprout, or find us on your favorite podcast platform. Also, subscribe to the Next Curve research portal at www.next-curve.com for the tech and industry insights that matter and all the semiconductor, chip, and AI goodness that you could ever ingest in less than an hour. Gentlemen, take care.
Take care.
Take care.